The question says, the coordinates of the vertices of triangle JKL. Oh, you didn't miss number 5 now. Okay. Oh, that's right. You're right, because I had to actually go and grab it from Liam's test because I was looking at yours and I'm like, oh, you didn't miss this one. Okay. Thanks, Madeline. The coordinates of the vertices, they're just the corners. The triangle has 3 corners, right? So that's just a geometry word for the corners of the triangle. They're at coordinates 1, 4, that's point J, point K is at 6, 4, point L is at 1. And then we have some new coordinates. If you see the apostrophes in geometry, we call those prime. So J prime, K prime, L prime, and that tells you some sort of a change occurred to triangle JKL up here. Something, it moved somewhere. So now there's new corners for this triangle. They're at 0, -4, -5, -4, and 0, -1. And you want to know, what's the sequence of transformations that maps triangle JKL to triangle J prime, K prime, L prime? These questions are very hard. So this is probably one of the most missed questions on the test. There are different ways. Some people can just see this more easily than others. I would suggest, especially if you have a hard time with transformations, to try graphing this. So I'm going to try and pull up some graph paper real quick that we can add to this screen. And I just am remembering I switched computers over the summer because I had some graph paper PDF saved, but now I don't. So let me grab one here. Let me try one more. Usually it's not this difficult. Okay, let's see. Let me try one more time. All right. Okay, here we go. I'm going to cover up your initials just for the moment, but they're still behind the graph paper. All right, so I'm going to graph these points. Now, the other thing that we can do, you can use, if you guys remember in the course, they show you how to do this with the coordinates. They show you how to apply different transformations with the coordinates. So we can try that also. Sometimes it just helps to see it, though. So I'm going to graph point J. K is at, anyone want to help me out? Graph point K and point L. K is at 6, 4. See, I got point K. Can somebody put point L up there? 1, 1. All right. Point L. All right, and so if I connect these, I'll get my triangle, right? So here's what my triangle looks like. Move that up just a little. And it says that we move. So let's put the new one in green. How's that? J prime is at 0, -4. So 0 left or right, down 4. That's J prime. K prime is at -5, -4. So we go left 1, 2, 3, 4, 5, down 1, 2, 3, 4. Right there is K prime. And L is at 0, -1. So 0 left or right, down -1. Oh, sorry, I'm writing -1, not L prime. L prime is what I mean to put there. Okay, does that make sense how I graphed those? We haven't talked about the transformations that occurred, but do you guys see where I'm getting triangle JKL and J prime, K prime, L prime from? Give me a thumbs up or smiley or hop on the mic, say, yes, I'm with you. You guys with me? Yes? Okay. Liam's with me. Janelle's with me. Good. Okay. All right. Perfect. So, so then what we can do is you have multiple choice answers. Well, not multiple choice, drag and drop answers down here. So what you could do is you could try these. You could see which ones work. That's one strategy. So for example, Liam, you put, first I think we reflected across the x-axis and then rotate it 90 degrees. Okay, so you could try it. And again, that's why these are really hard. This is probably one of the most tedious questions. This is going to take us a while to figure out. So if I just try, I'm going to try 1 point. So let's try point L, for example. If I try this strategy, I'll just show you what this would look like, Liam. If I reflect point L across the x-axis, I'm going to put this in red. What that means is it's going to be exactly this. So the horizontal axis is your x-axis. Right now, L is 1 above the x-axis. So if I reflected across the x-axis, it would be 1 below the x-axis. So it would move here. So that would be the first, if I reflect it. Then if I rotate it 90 degrees counterclockwise, what you do to visualize that is connect the point to the origin. And then you're going to come off of that 90 degrees. The way you're going to come off that depends on whether it says clockwise or counterclockwise. So if I'm thinking of a clock and I'm thinking of the hands on the clock, the counterclockwise would mean that I would go this way. That's the opposite way a clock's hand moves. So when I make my 90-degree line, I'm actually going to go back. I would go in that clockwise direction, and I'm going to put a little box right here, and that just shows that that's a 90-degree angle. Okay, so I could have, so that's how I made this line. I could also make it coming this way, but that would be if it said clockwise. So this is counterclockwise. So that means my point would end up right here. That's actually where I started. Does that make sense? This is kind of hard to describe. These transformations are one of the hardest things to do in Neuro. Can you guys follow what I'm saying? So if I take point L at the blue and I reflect it across the x-axis, so I'm just trying things out. I'm just playing around with this. I'm just going with Liam's initial answer. That means it would reflect over to here. If I apply the 90 degrees counterclockwise, I go back to the origin, 90 degrees off of that in a counterclockwise direction, and I would end up back where I started. So that is not where we want to be. It's actually saying we're going to end up here. So do you guys see what I'm saying? You could try graphing it, try applying the transformation and see if it actually ends up where it's supposed to be. I'm not seeing a lot of like, yes, I'm following you. I'm with you, Miss Williams. Are you guys lost? If you're lost, that's okay too. Let me know. Like, I have no idea. Okay, kind of. Okay, and that's fair. That's fair. Isaac's with me. Liam, how are you feeling? We're not done yet. This is just an example. Okay. A little lost. Okay, that's fair. That's what I need to know. Okay, that's what I need to know. Okay, so let me show you one more, because especially the 90 degrees counterclockwise thing, I think that's really confusing. Let me show you with one other point. What I'm going to do, though, is I'm actually going to take off the red because our graph just might get a little messy. So I'm going to show you the same steps just because I want you to kind of see how do you actually do this on a graph. So I'm going to do the same thing with point J. So I'm going to say, let's just pretend we're checking out this answer, Liam. It's already in red. We know it's incorrect. But just for the sake of like learning what do these things look like, let's just practice. So reflection across the x-axis. If I reflect point J across the x-axis, can you all grab your pointer hands and show me where you think it would end up? So look at point J in blue. If I reflect that point across the x-axis, where do you think I'd end up? Don't move it around. It should be in an exact spot. It should be in an exact spot. There you go. Very good. Okay, so this is the x-axis. This is the y-axis. So yes, exactly. If I reflect point J, right now point J, especially if you look at the coordinate, it's 4 above the x-axis. If I reflect it across, it's going to be 4 below. Okay, so it would be where that red dot is. Okay, so that would be if I applied this first transformation. Now I'm going to apply the second one and see where we end up. So this is the one that's a little harder. Reflections, I think, are a little easier. Rotations are difficult. So to do a rotation, what you do is you're going to connect that point to the origin, to the point where the x and the y-axis cross. Which direction? Grab your pointer hands again. If I am right here at point J, or this would be J prime, if I go counterclockwise from there, which way should I be going? What's counterclockwise from this red dot? Just now you can move your pointer hand around. So think about a clock. Think about, and this is like, I know you guys are probably used to digital, but think of an analog clock. Which way do the hands go? Counterclockwise means you're going to go the opposite way. Good, good. I see that pink one. That's moving in the correct direction. Good job. So we actually would be going this direction, counterclockwise. Okay. So I'm going to draw my 90-degree angle is going to come off of that origin value, but it's going to be in the counterclockwise direction. And actually moved it a little too far. Okay. And so that would mean that J prime, if I do those two transformations, J prime would end up at +4, +1. Where I want it to be, if I did this correctly, is down here, because it says J prime should end up at 0, -4, if I do this correctly. So do you see why this would not be the right sequence, Liam? Are you guys understanding how I'm doing these? We already know this is incorrect. We're just playing around with like, how do you actually apply these transformations on a graph? Okay. Okay. Liam's with me. All right, now I'm going to take off all of this red stuff. Now we're going to do the right way. Okay. So the correct answer would be translation 1 unit left. So it's actually this one should go in the first spot. And rotation of 180 degrees about the origin should be number 2. So let's try that and let's see if we end up where we're supposed to be. So if I take translation 1 unit left, that means that the entire triangle is going to shift 1 unit left. So I just go point J, move it over to the left 1. Point K, move it over to the left 1. Point L, move it over to the left 1. So my red triangle would be, that's where I'm at after this first sequence. Oops. Okay. Do you guys see that? Do you see how the red triangle just, it's just taking the blue triangle and shifting it over to the left by 1? Give me a thumbs up or a smiley face or say, yes, I'm with you. Okay, Liam's with me there. How about everybody else? Madeline, are you with me? Isaac, Janelle, how are you guys feeling? Dahlia, you're with me? It's okay to say no. I'm just checking. You guys got to talk with me. Okay, so we're just took the blue triangle and we went boop, 1 over to the left. Okay, because we're saying, okay, well, what if we do this first? Translation 1 unit left. So we're saying if this is our first, let me maybe write that here. Can't log in. I don't know why it won't work. Try like 100 times. All right, I'll help you later. All right, and then we're going to do this second, number 2. Now we're going to rotate 180 degrees about the origin. So 180 degrees is easier than the 90-degree clockwise thing, I think. All you do to do that is, actually, let me change color. I'm going to do green. You connect the point and you just pass through the origin. Oh, that's not a good color. Let's try. How about golden color? Here we go. So we're going to do point L, which is the red in the red. You draw a line through the origin, which is the point 0, 0, and you just make it pass through an equal distance. So point L prime, right here in red, that's where L moved currently. Okay, we've only done one transformation so far. We're applying our second transformation right now. So we're drawing a line through the origin. It's going to go the same distance on the other side. And this one's pretty straightforward because it was lined up with the y-axis. Okay, and J is also going to be a little easier because it's also lined up with the y-axis and it's going to overlap my other. But that makes sense because this is J prime at the moment. And if I go through the origin the same distance on the other side, J prime would end up here. And that's looking good so far. That's where we want it to be. So now we just have to check K. So right now it's on the red dot. So I'm going to take a line. Now, if I was doing this on graph paper at home, I would use a ruler. You got to use a ruler. I'm going to connect it through the origin, the same distance all the way to the other side. Just a straight line, just making sure that the length from the origin on this side, so from 0, 0 to the point that I'm moving, the length of that line and the length from the origin to the other side are the same. So that does match up with where we want K prime to end up. So number 1, the first thing you would do would be translation 1 unit left. Number 2, rotation 180 degrees about the origin. Okay, like I said, this is one of the most difficult questions on the test. How are you guys feeling about that now that you saw the correct way? Did you follow along? Are there questions I can answer? If you can hop on the mic, that would really help me out, just because, especially if you have a question. Just feel free to ask it. Do not be shy. Learning is, you have to make mistakes. You have to. If you already knew everything, you wouldn't need this class, right? So mistakes are totally fine. Questions are totally fine. That is exactly how you learn. If you don't make mistakes and you don't ask questions, you can't learn anything new. Okay. All right. How are you guys feeling overall about this one? Did you follow most of that? Okay. And hopefully this one, I know I spent quite a bit of time on this question, but hopefully we covered 3 different types of transformations in this one question. Or actually 4 different types of transformations. So I hope that helped. Janelle, Isaac, how are you guys feeling? Eli, it's okay to be like, I don't know. Okay. It's like I'm pretty good. Okay. Sorry, maybe it didn't go the first time, but I see it now, Janelle. Thanks. Yeah, I see it now. Okay, cool. Good. Okay. All right, Liam. So perfect. I will add your points back there. I'm going to start keeping track of what we went over. All right. So it'll take me, after we get done, I'll try to go back in and I'll add half points back so your scores should look better. Okay. So Liam, I think that's all you had. Did you have a question on, I don't know, real quick, let me just share. Oh, you did. Okay. Yeah, well then just stick around. All right. So we took care of number 5. All right. Let's try number 3 next. But like I was going to say, it'll take me a little bit after we get done here. Be patient with me, but I will get your points added back. If you don't see them by this afternoon, definitely feel free to remind me and be like, Miss Williams, why do I not see my points back for the Unit 1 test? All right, so your number 3 might have looked a little different but go ahead and take a look at your test. Look at number 3. This one says, what is the name of the line of reflection for the pair of figures? So you're what you're doing here is you're looking at the arrows, and you're trying to figure out which line would be line P, line Q, or line R. Which one would be, like if you placed a mirror there, that's what a line of reflection really is. If you placed a mirror at one of these lines, which one, if you were standing here at this arrow, you'd see this arrow. So QR, that one would have been incorrect because you'd be naming 2 different lines. So in other words, it's saying pretend you only have one line at a time. So for example, if you only had line P here, let's say you took away line Q and you took away line R. If you just had line P and you put a mirror here, this part of the arrow would get reflected to the left. Can you guys visualize that? That's what makes some of these very hard, is it's a lot of visualization, which some people are better than others with. It's one thing that's tough about geometry. So it wouldn't be line P. But if you put a mirror here at line R, okay, and again, try really hard to just erase line P and erase line Q. Imagine they're not there. And you were standing here at this arrow, you would see this arrow on the other side of the mirror, right? Can you guys picture that? So that's why the correct answer is R. Okay, so go ahead and put your name here on this slide, or your initials if you missed this one. So take a look at your test. Again, you should all have that open. Take a look at that and put your initials somewhere on the slide. It just questions like we did on that first question that we spent like 20 minutes on. This one's a little different presentation of it because they're giving you the coordinate rule. So I'll show you guys how to do transformations this way. The directions say graph the image of the given triangle after the transformation that has the rule xy goes to x negative y. Okay, so here's how this works. This is also a bit tricky. xy represents your original point. So what I would like you guys to do, go ahead and put your initials up on the board if you're still working on that. Once you do that, though, what I want is grab your tools and write or type out, tell me what the coordinates of these 3 corners of the triangle are. So tell me the x and y value. Just write it here on, like next to the point. Okay, write the x and y value there. Perfect, Dahlia. Thank you so much for doing that. Very nice, Janelle. 2-7 looks great. Hey, multiple answers on there. I love it. Thanks, Madeline. All right, and what about that third one? Sorry, that was a little loud. Trying to drink my water. Oh no, Janelle. Try refreshing. Try refreshing your screen. You know where the refresh button is? Okay, yeah, try that. Very good. 5, -2. Excellent. Nice work, guys. Okay. Or I should say -5, -2. I missed the negative. That's important. Perfect. Okay, great. Now, I actually really like that there's multiple answers up here. What I'm going to do is I'm going to borrow one of these real quick. I'm going to borrow Janelle's. Good. I'm glad it was working, Janelle. That's awesome. Okay, and I'm going to, I'm just going to kind of line these up, organize these. Okay, and let's also, can somebody write the third point over here, 4, -3? And what we're going to do is I'm going to show you what this means. Okay. Thank you so much. Perfect. Okay. So what this means, once you get the hang of it, it's not bad. I know right now, like, especially when you first do these, you're like, what in the world is that telling me to do? So what it's saying is, it's telling you to first label, and what will really help is to first label your starting value. So I'm going to label this one X, Y, X, Y, X, Y, okay? And then it's saying that for each of these points, I'm going to make a change. That's what the arrow indicates, that we've done a transformation. And it's saying that I'm going to make it look like X negative Y. So the X is talking about your original X value. So if you've labeled it and you know, okay, X for this point, X is 2. Then when I come over here and I've done my transformation, I'm just going to write 2. That's my X value. I'm going to write 2 there again. Okay, so this first point, if I apply my change, is going to be 2, comma, and then it says to take your Y value. So my Y value over here was 7. It's saying to keep it in the second spot, but we're going to make it the opposite sign. So it was a 7. Now I'm going to make it a negative 7. And that's where it's going to end up after I apply my transformation. Can you guys try that for this point and this point? These are a little bit harder because they have negatives, so be careful. But give it a try. You got to try it. Let your brain wrap around the problem. Even if you're incorrect, that is okay. I will help you out with it. But give it a try first. See if you can figure it out. Did you miss this one, Liam? So I know Dahlia, Madeline, and Janelle did. Eli, Isaac, did you guys do okay on this one? Did you miss this one? It's number 8. You didn't? Okay. Eli, Isaac, did you guys miss number 8? Okay, we're at Isaac. Yes, please. Do you have your mic? That would be awesome if you'd hop on your mic and ask your question. It's so much easier that way. If not, you can type it, but I would love to hear your voice. So go ahead, once you guys think you have the answer, write this up here. You could write your answer of where do you think 4, negative 3, what do you think happened to it? Where would it move to? Oh, I love it. I'm seeing some graphing going on. Perfect. Yeah, that's where that first point would have ended up at. Yeah, maybe we should color code. That would be a good idea. Let's put the second one in green. So where do you think the second point moved to? And then let's do the third one in red. Where would that third point move to? And just to get used to the notation, let's call this point A and point B and point C. So if this is where A moved to, we would call this one A prime, right? What's your question, Isaac? You want me to just kind of rephrase again? So what we did first was we identified what the coordinates of the corners of the triangle were. In other words, the vertices. That's the official geometry word. And okay, yes, I totally get it. Try it though, okay? Try it with these 2 points. Try it on your own, Isaac, because that's really the way you're going to know whether you either get it now or you still need some help. But for point A, we're calling this one point A, we said, okay, the X value is 2, the Y value is 7. Does that make sense? Do you know how to find the X value and the Y value for a point? Because I know sometimes that can be like you kind of forgot how to do that from a prior math class. So you start at the origin and we go to the right 2 and we go up 7. So that's what it's like, an address, like you're telling somebody how to get to the house. So a really good way to remember how to graph points if you have a hard time identifying the address of a point is you always start here at the origin and then think of it as a really tall building. Let's say we're going into, like the Empire State Building, okay? Well, the first thing you have to do when you go in a really tall building is you have to find the elevator. right? Unless you want a lot of exercise. So you're going to either go left or right. You're going to be on the ground floor finding where that elevator is. So the first number is always your ground floor number. In other words, your x-axis. Okay. So if it's positive 2, that means you're going to go right 2. Okay, there's my elevator. I get on the elevator right there at number 2. And then I tell it what floor to go to. So I'm going to go up to floor 7. Bing. That's where my stop is. I'm going to get off. Okay. Or if the point is at 4, -3, that's telling me, okay, I'm going to find the elevator by going to the 4th elevator over to the right, since it's positive, and then I'm going to go down to the 3rd floor, underground. Okay. All right, good. Let's see. So I'm seeing 5, 2 here. Close. Close. I agree with the 2. I'm going to give that a thumbs up. The 2 is good because you took the y value and changed the sign. So that's what this means, is you take the y value and you make it the opposite sign. But the x value is staying. In other words, you don't see a negative sign there, so you don't need to change the sign on the x. So you take the x just as is and rewrite it for the new point. What about this one? So, well, let's finish this one first. So what would the x value be? We're jumping down to point C, but can you tell me? Anybody tell me what the x value to begin with, to start with, is -5. This is saying just copy it over. You don't have to do anything to it. Just copy it on over. What would it be instead of +5? There you go. Yeah, -5. Good. Very good. 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 Okay, I see a couple different. Yeah, I see one on the board now. Good. So I'll put that in yellow. So this would be -5, +2. All right, now let's do the last one, point B. So my x value originally is 4, +4. So this says don't change it, leave it as is. So what would I have for my new x value? Even though I've done a transformation, in this particular one, we don't have to do anything to the x value. Do you guys see what I'm saying? Janelle, are you with me, Dahlia? Okay, this is close. It's actually the with the x value, you don't have to change the sign. With the y value, you do. So this means that the x value, just keep it. Don't change it unless you see a negative. If you saw negative x here, then that would say to change the 4, change the sign on the 4. But it's just saying take this as is. It was +4, just keep it +4. Okay. So this is going to be 4. Now with the y value, when you see the negative, that means change the sign. So my original y value was -3. If I change the sign on -3, what would it become? Yeah, good. +3. Very good. Good. Yeah, and Madeline, you got that. Very good. Very good. Okay, so now let's go ahead and graph this. And this is what I know part of this. Now be sure you have a chance to practice these, because I know part of this is like, how do I actually use the tools on the test to make this do what I want it to do? So in your lessons, there's practice problems where you have these same tools and you're supposed to be in there practicing so that when you go to the quiz or the test, you know how these work. So just FYI, in case you didn't know that, that's what you should be doing. Okay. So we're going to just go ahead and take 4, 3 and graph it, and negative 5, 2. Can you guys, maybe somebody grab green? Do you guys know how to change your color? Graph the point 4, 3 and then grab red. Oh, I used yellow. Sorry, I should have used red. Grab red and graph negative 5, 2. Good. All right, and then I'll connect those together. We'll connect in yellow. Here we go. Good. Okay, so we're going to connect. So we have 4, 3. That would be B prime. And we have negative 5, positive 2. That would be C prime. And that's what your final answer should have looked like. That's what your sense. Do you guys feel like you are understanding that a little bit more? Give me a